In this video, I'm going to bring you along on a challenging plumbing installation job. We're installing a water intake line in a setting that has pretty much no soil. There's a little bit of soil, but most of it's bedrock. We're going from an existing well to a new building, and we're using a kind of electric heating cable called a retro line. This is meant to go inside of existing water pipes. In this particular installation, we're putting in some new pipes too, so you'll get a better look at how retro line works and how the pipe is going to be insulated and how that insulation is protected and things. But for now, just take a look at this overview of how the retro line system works. Keep it in mind as you see us installing the different parts of the system, and maybe something like this makes sense for you where you are.
One thing to understand is that all of this hardware is drinking water safe, so it's certified for potable water use. The system we're installing, as I mentioned, is called a retro line by a Canadian company called Heatline. This is the 1.25" black poly pipe that runs from the well to the building, and it's going to have a heating cable inside, but there's also going to be some pipe insulation on the outside, and that's what this stuff is here. It's a foam sleeve with some adhesive on the joining parts here. So the strips get pulled back during installation, and then the adhesive is forced together and it kind of seals together into a circle. So here I am putting on the pipe insulation. There's nothing complicated about it. You just want to make sure that the pipe is fairly clean, and then you open up the seam on the foam and surround the pipe before pulling off all of the yellow tape that covers up the adhesive. Here I am pulling off those yellow strips, and I'm going to be bringing the adhesive surfaces together to unite the foam, and then I'll be pushing the foam all the way into that white PVC pipe you see to the left. Eventually, that outer white pipe will continue all the way to the well, encasing the foam and pipe as we go. But it's got to go on one length at a time because we can't slide the PVC over all of the foam. So we do a couple of lengths of foam, and then a length of PVC, and then more foam eventually till we get to the well. But right now, I'm slipping that foam into a chunk of PVC that's going underneath the edge of the foundation. This is actually a great spot to show how shallow the soil is here. That footing is right on top of bedrock, and there just happened to be a crack in the rock that we're using to actually get inside the building. Here you can see the pipe and the insulation. Now we're on the inside of the footing, on the inside of the building. So here we are sliding on a full length of 4-inch PVC. It's going to be going over the insulation and the pipe. And the trick with something like this is to get the joints secure and waterproof. There'll be some PVC cement on the end. My friend Brad, this is his place, he's using a sledgehammer and a little block of wood to tap the end of the pipe so that we get a nice complete connection where everything's strong and waterproof. So it's more of the same as far as insulation goes. We're putting in another section here, doing up the joints, sliding another piece of PVC over, just until we get to the well. Everything will be insulated, encased, and protected. Optionally, Heatline also offered heavy black tape for sealing the joints from one piece of foam to the other, and anywhere along the foam where that self-adhesive joint is opening up. Now it's the fun part. We're installing the electric heating cable inside the water intake line. So this puts it in a really good position to keep the water from freezing. This is the same pipe that you saw outside with the insulation and the encasing white pipe on the outer side. And this cable goes all the way through to the well. And it actually is going to come out of the pipe and then go down the well for some distance. Normally, this operation would happen as the cable is being unraveled from the reel that it's packed on, but we've got the cable out in the open here so you can better see what's going on. This cable is unique too in that it provides more or less heat along its length depending on the surrounding temperature. So if there's a cold spot, the cable's going to put out more heat in that area, and if there's a warm spot, it'll put out less. Now, it's not able to completely shut itself off, so an optional thermostat is available. This reduces energy consumption even more, which I'm going to be showing you about soon. This is the end of the water line. We're not connected to the well yet, but you can see the end of the heating cable coming through. There's probably enough to go down the well 3 or 4 feet. This particular well, I don't think it's going to freeze very far down, even though the frost line is about 4 feet below the surface. This well is full of water, and the well actually flows, so it's probably not going to need 3 or 4 feet of protection. Here's that unusual well, just a hole drilled directly into bedrock. If you were connecting to a lake or river, then you'd run the heating cable through your water line all the way to the point below the expected frost level. And if you're connecting to a regular well, the heating cable goes right up to the casing, but then stops. If you remember earlier, we threaded in the heating cable into the pipe, and now I'm installing a T that allows that heating cable to exit the pipe without any water leaking out. So this T came as part of the kit. It was already on the cable, and it's just near the end that you plug in. The fittings go together like this. That's the heating cable there, and the water flows through the fitting. You do need to tighten these up with a wrench. I mean, they're all plastic, so you need to be careful about it, but slip lock pliers like these do a good job tightening. Just make sure you don't tighten the fitting in the middle of the T where the cable comes out. It's already been fully tightened at the factory. So this is the thermostatic control that heats things, or keeps things going properly. This plugs into a wall outlet, and then this cable here plugs in here. And this can be set to come on and off at different temperatures. And over here is the temperature sensing probe that will go down into the casing to measure the temperature inside the pipe. The temperature probe here needs to be located in what you expect to be the coldest part of the system. So I'm threading it down into the outer PVC, past the footing and into the cold zone outside the building. This will provide information to the thermostat so it can do its thing, shutting the power off, turning it back on, according to your settings of the thermostat itself. So it's been more than a week since we started the project, and everything's in place now. We've had some really cold weather, some snow. All that remains now is to rebury the line, but even without being buried, the water's been flowing perfectly, and Brad can expect running water year-round without any freezing hassles.